Today, our group will do an assignment about the death rate in Malaysia from 2000 to 2020. To start with an introduction, in general, Malaysia death rate from 2000 to 2020 was low and fairly stable, reflecting the country's progress in healthcare and public health initiatives. Over the 2 decades, improvement in medical infrastructures and disease prevention contribute to maintain control over mortality. However, a slightly upward trend was observed in the later year, primarily due to an aging population and the emergence of chronic and lifestyle-related illness. By the end of the period, the onset of the COVID-19 pandemic further impacted the mortality figures. This overall pattern highlights the dual challenge of managing traditional health concerns while addressing the growing burden of non-communicable disease and emerging health crises. That's all from me. Now I will pass the next slide to Zahran to explain more about the graph and table of data.
Thank you, Amiro, for the introduction. Now, let's take a look to the table of the data. Here, we have a comprehensive table of data spanning from year 2000 until year 2020. The value under the first column represent the years of the data, while the second column represent the value of that for that year in Malaysia. If we take a closer look, we can observe that there is an upward trend from year 2000 until 2020, which means the data is a growth type data. Next, let's move on to our graph. As you can see, the graph on the left side is the particular solution graph for the data, which we substitute original data into a formula which will be explained later by my friend. And the graph on the right side is a graph for the original data. Both graph is plot against year starting from 2000 until 2020. Now, let's Afiq Zubai continue our video.
Thank you, Zaran, for the explanation before. Now, let's take a look about the general solution for explanation in our model. Here is the differential equation that given. dd over dt is equal to kd. Separating the variable and integrated both sides, and it gives ln d is equal to kt plus c. And now we rearrange them, and we got d is equal to a times e power of kt. To find the particular solution, we use the initial condition at year 2000, where is t is equal to 0 and d is 102,000. This gives us a is equal to 102,000. So, the general solution becomes dt is equal to 102,000 e power of kt. Next, we need to find the value of k by using the data from year 2001, where t is equal to 1 and d is equal to 10,000 at 103,000. Substituting into the equation and the solving for the k value, it will give us 0.00975. Now, our final model is dt is equal to 102,000 e power of 00975 t. And finally, we need to predict the number between the future and the past value. So first, we need to for the past we use the year 1999. So let t is equal to -1. So we substitute the value -1 into the formula, and then we got 101010.3325, and that's approximately to 100,000 1010, and that's in 1999. Next, for the future, we use for the year 2021, and we let t is equal to 21. So we substitute the value of 21 into the formula, and now we already predict the number of deaths in 2021 is equal to 125176. As we can see, the model reflects a gradual increase in the number of deaths, showing how exponential function can be used to project trends over time. That is all from me. Now I will pass to Haziq.
Now Haziq is here. Thank you for my friend Zubai, that has helped me to explain about the little bit of the derivation for the equation. Now I will explain and answer about 5 questions from the analysis. For the question 1, we are calculate the particular solution are accurate with the actual value. Based on our calculation, the value that we calculate from the particular solution are not accurate with the actual value. For the second question, we need to determine if our data have any percentage error. So we have discovered that our data are not accurate, that we calculate the percentage error using the formula, which is the actual value minus theoretical value and divide by the theoretical value and multiply with the 100. So we got the percentage error with the value, which is 16.14% percentage error. So for the next question, which is question 3, if there is any difference between the actual value and the value calculated from the particular solution, based on our discussion and our opinion, they are slightly different between the actual value and the value that we calculate from the particular solution for our past value, while they are significantly different between the actual value and the particular value that we have calculated for the past value. For the question 4, what are affected of the population growth in the past? Based on our research and discussion, high birth rate from the 1950 to the 1970, especially in a rural area with limited access to the family planning, significantly boost the Malaysian population growth. For the last question, which is question 5, what we must think that what our team think that might affect the population in the future. Based on reality, the value in the future might be affected the population by the disease. For example, in 2021, a new virus was discovered, which is the COVID-19, that increased the total of death in the Malaysia. Okay, that's all from me. I will pass to my friend Aiman for the conclusion of task 1.
So, in conclusion, from the year 2000 to 2020, Malaysia maintained a relatively low and stable death rate. During these 2 decades, there wasn't a dramatic increase in overall mortality. However, there was a slight upward trend over time. This gradual rise can be linked to 2 main factors. That is, the aging of Malaysia population and an increase in cases of non-communicable diseases such as heart diseases, diabetes and cancer. Then, in the year 2020, the onset of the COVID-19 pandemic began to shift these mortality patterns. The pandemic introduced new public health challenges for Malaysia as it did for countries around the world. Despite these challenges, Malaysia demonstrated strong public health resilience throughout this period. The healthcare system's ability to manage both existing health issues and emerging crises like COVID-19 reflects the country's commitment to public health. Looking ahead, future trends may show a more noticeable impact from chronic diseases and the aging population. This will be important factors for Malaysia to address in order to continue protecting public health in the years to come. Thank you. So, now we would move on to task 2, and I will invite Faik Daniel to present it to us.
Okay, so hello everyone. Today I will be presenting how we use the Newton rational method in Excel to approximate the root of the function. So as you can see, this is our question, which is we will be given the function of fx equal to 3 ln x cubed plus 2x minus 3 over 2 xe. So we were told that the root lies between 5 and 15, and our goal was to find the value of x for which fx equal to 0, accurate to 6 decimal places. Okay, so first we need to understand the Newton-Raphson method. The Newton-Raphson method is an iterative numerical method used to find roots of real value function. The formula is, so we need a function which is fx, its derivatives which is f prime x, and a starting guess for x. In this case, for the function, I will simplify a 3 ln x cubed to 9 ln x. So the formula becomes fx equal to 9 ln x plus 2x minus 3 over 2 xe. Then I will calculate the derivative, which is f prime x equal to 9 over x plus 2 minus 3 over 2 e. So for the second step, I will setting up the Excel. So in Excel, I made a table with the column x. So this is for our current guess. Fx, we will be using the formula. F prime x, we will be using the derivative formula. And with the Newton-Raphson method formula, we will find the next approximation of x. So I will started with an initial guess of x equal to 10. At x equal to 10, fx was slightly negative, about negative 0.050962, and f prime x was about negative 1.177423. Using the Newton-Raphson method, I calculate the next approximation of x is 9.956718. So for the second iteration, fx become even closer to 0, which is negative 0.000885. And the new x value was 9.956646. And the third iteration, fx become exactly 0 to 6 decimal places. So we find the root, which is x equal to 9.956646. So for confirming the answer, I also included a draft of the function to visually confirm that there's a root about this value. And as you can see, the curve crossed the x-axis just before 10, which matches our result. So for conclusion, so by using the Newton-Raphson method in Excel, starting from x equal to 0 and iterating just 3 times, I found the root of the function is approximately x equals to 9.956646, correct to 6 decimal places. So thank you guys for watching. I hope you guys satisfied with our explanation and presentation about task 1 and task 2.